Military procurement contradicts civilian consumer logic. Armed forces in 2025 continue operating weapons designed in the 1930s through 1970s, not from desperation, but from deliberate strategic choice. To understand this phenomenon, we must examine the context that produced these systems and the economic realities that sustain them. The Second World War transformed military production. Between 1939 and 1945, the United States manufactured over 2.6 million military trucks and 300,000 aircraft. This industrial mobilization created standardized weapon systems designed for mass production, battlefield reliability, and logistical simplicity. The Cold War imposed different constraints. Nuclear deterrence and proxy conflicts created demand for weapons effective across asymmetric scenarios. Defense budgets faced competing demands, while weapon systems reflected compromise between performance, cost, and strategic uncertainty. By the 1970s, military doctrine had crystallized around specific operational requirements. Modern militaries inherited arsenals sized for total war, but operate under peacetime budgets. A single F-35 fighter costs approximately $80 million. Replacement isn't merely technological. It's fiscal, logistical, and doctrinal. Popular media presents military technology through perpetual obsolescence. Defense marketing emphasizes revolutionary capabilities, while video games depict near-future battlefields where aging equipment represents failure. This narrative distorts operational reality. The United States operates B-52 bombers introduced in 1955. Russian forces deploy T-55 tanks designed in 1946. These represent deliberate strategic choices based on operational effectiveness, economic rationality, and proven reliability. The myth assumes linear technological progress. Reality involves complex trade-offs between capability, cost, logistics, training, and doctrine. Designed by John Browning in 1918 and standardized by 1933, the M2 Browning emerged from World War I requirements for long-range suppressive fire, exceeding the .30-06 in 1919. The operational need was clear: defense against aircraft, light vehicles, and fortified positions. The interwar period demanded weapons adaptable to uncertain future conflicts. The M2 fires 12.7 by 99 mm NATO ammunition with an effective range of 1,800 meters against point targets. Cyclic rate reaches 450 to 600 rounds per minute. Weight is 38 kilograms for the gun, 20 kilograms for the tripod. Muzzle velocity achieves 890 meters per second. The design features short recoil operation with rising bolt lock, exceptionally robust construction allowing sustained fire, and simple disassembly requiring no specialized tools. The weapon functions in temperatures from -54 degrees Celsius to +63 degrees Celsius. Its limitation is weight, restricting mobility in dismounted operations. The .50 BMG cartridge penetrates light armor and destroys equipment beyond small arms range. No shoulder-fired weapon matches this combination. Per unit cost approximates $14,000 versus modern replacement proposals exceeding $35,000 without performance advantages. Ammunition standardization across NATO means every supply chain stocks .50 BMG. Replacement requires new ammunition production infrastructure, a multi-billion-dollar investment. U.S. Army, Marine Corps, and Navy employ the M2 on vehicles like Humvees, Strykers, and MRAPs, on aircraft as helicopter door guns, and in static positions. Australian, British, Canadian, Israeli, and South Korean forces maintain similar deployments. The weapon serves in vehicle weapon stations, base defense, long-range precision fire, and anti-drone systems with modern optics. Designed between 1948 and 1952 during the early Cold War, the B-52 Stratofortress addressed intercontinental nuclear strike capability against the Soviet Union. In the absence of reliable intercontinental ballistic missiles, strategic aviation formed the basis of nuclear deterrence. First flight occurred in 1952. Operational service began in 1955. Production ended in 1962 with 744 aircraft built for long-term service in an environment of rapidly changing technology. The B-52 carries 5 crew members and 8 Pratt and Whitney TF-33 turbofans with modernization to Rolls-Royce F-130 engines planned. Unrefueled range reaches 14,080 kilometers, effectively unlimited with aerial refueling. Service ceiling is 15,000 meters. Payload capacity is 31,500 kilograms of ordnance. The high-wing design allows ground clearance for large munitions. Internal bomb bay plus external hardpoints accommodate conventional bombs, precision-guided munitions, cruise missiles, and naval mines. Over decades, the aircraft has received digital avionics, modern radars, electronic warfare systems, and high-precision cruise missile deployment capability. Its limitation is low survivability in areas with modern integrated air defense systems. The B-52's key mission, launching long-range weapons outside enemy air defense zones, remains relevant. Flight hour cost approximates $72,000 versus B-2 Spirit at $135,000. Structural inspections indicate viable service to 2050. Operation and modernization cost significantly less than developing and manufacturing a new bomber with similar payload capacity. Visible deployment demonstrates resolve without escalation. The U.S. Air Force operates 76 aircraft based at Minot AFB, North Dakota, and Barksdale AFB, Louisiana, with rotational deployments to Guam, Diego Garcia, and Europe. Used for nuclear deterrence, conventional bombing in permissive airspace, maritime strike, long-range cruise missile delivery, and close air support with precision munitions. The Douglas DC-3 first flew in 1935 and entered commercial service in 1936, revolutionizing global aviation. It was the first aircraft that made airline passenger transport consistently profitable without government subsidies. When World War II began, the airframe was militarized as the C-47 Skytrain, becoming the logistical backbone of Allied air operations. Between 1940 and 1945, over 16,000 C-47 variants were produced. They supported every major Allied operation: Normandy, Market Garden, Burma, North Africa, and the Pacific. After the war, thousands were sold into civilian markets, creating a unique overlap between military and commercial aviation unmatched by any other aircraft. The C-47 is a twin-engine, low-wing transport aircraft powered by 2 Pratt & Whitney R-1830 radial engines producing 1,200 horsepower each. Maximum payload is approximately 2,700 kilograms, or 28 fully equipped troops. Cruising speed is 290 kilometers per hour, with a range of roughly 2,400 kilometers. The aircraft is capable of operating from short, unpaved runways and requires minimal ground infrastructure. Its systems are entirely mechanical or analog. No fly-by-wire, no integrated electronics. The airframe is overbuilt, designed to tolerate structural stress, rough landings, and poor maintenance environments. Limitations include low speed, lack of pressurization, and vulnerability in contested airspace. The DC-3 remains in service because it performs tasks that modern aircraft often cannot do economically. It can operate from remote airstrips where infrastructure is minimal or non-existent. Maintenance can be performed without specialized tooling, advanced diagnostics, or proprietary software. Spare parts remain available through civilian markets, refurbished stockpiles, and continued aftermarket production. Operating costs are extremely low compared to modern turboprops. For cargo, paratroop training, humanitarian aid, and regional transport in permissive environments, replacement offers no meaningful advantage. DC-3/C-47 variants remain operational in parts of Africa, Latin America, Southeast Asia, and the Arctic. Military and government operators use them for transport, training, surveillance, and parachute operations. Civilian operators employ them in cargo hauling, scientific research, firefighting coordination, and polar logistics. Some airframes have accumulated over 70,000 flight hours, an unmatched record in aviation history. Designed in the late 1950s, the M113 addressed requirements for armored troop transport with amphibious capability and air portability. Intended for mechanized infantry in European conflict and flexible global deployment, the vehicle entered service in 1960 as a response to Soviet motorized infantry developments. Crew of 2, driver and commander, plus 11 infantry. Combat loaded weight is 11,300 kilograms. Detroit Diesel 6 V53T engine produces 275 horsepower. Road speed reaches 68 kilometers per hour, water speed 5.8 kilometers per hour. Aluminum alloy armor ranges from 12 to 38 millimeters thickness. Standard armament is M2.50 caliber machine gun. Aluminum armor reduces weight, enabling air transport. Box hull design simplifies production. Amphibious without preparation. Limitation is vulnerability to modern anti-tank weapons and IEDs. Over 80,000 produced created a global supply chain for parts. Configured as ambulance, command post, mortar carrier, anti-tank platform, and engineer vehicle, a single chassis supports multiple roles. Modernization, including improved armor, weapons, and electronics, costs $200,000 to $400,000 versus $5 to $6 million for new infantry fighting vehicles. Sufficient for low-intensity conflicts and rear area security. U.S. Reserve and National Guard units. Israel with heavily modified Zelda variants. Philippines, Taiwan, Thailand. Over 50 nations operate variants. Serves as troop transport in secondary theaters, command vehicles, medical evacuation, mortar carriers, and training platforms. Developed between 1958 and 1961 as successor to RPG-2, the RPG-7 addressed man-portable anti-tank weapons for infantry squads. Designed against NATO armor during the Cold War, with simple construction allowing production in low-technology facilities across the developing world. 40mm launcher tube accommodates various grenade diameters from 70mm to 105mm. Effective range is 200 meters against moving targets, 500 meters against stationary. Penetration exceeds 300 millimeters rolled homogeneous armor with PG-7V warhead. Launcher weight is 6.3 kilograms. Grenades 2 to 4.5 kilograms. Reloadable launch tube combines rocket motor with shape-charged warhead. Iron sights calibrated for standard grenades with optical sights available. No electronics or batteries required. Limitation is difficulty engaging fast-moving targets and poor performance against reactive armor. Defeats most armored vehicles except modern main battle tanks with reactive armor. Highly effective against bunkers and buildings. Minimal training required with no maintenance beyond cleaning. Millions produced across dozens of countries make grenades globally available. Launcher costs $500 to $2,000. Grenades $100 to $500. Destroys vehicles worth millions. Standard infantry weapon in Russia, China, Middle Eastern armies. Widely used by non-state actors globally. Employed for anti-armor, urban warfare, bunker destruction, asymmetric warfare, and defensive positions. Designed in the mid-1950s for medical evacuation and utility transport, the UH-1 proved air mobility doctrine during the Vietnam War. Over 16,000 produced, making it the most produced Western military helicopter. Development responded to Korean War lessons about helicopter battlefield utility. Crew of 1 to 4 depending on mission. Capacity includes 14 troops, 6 stretchers, or 1,800 kilograms cargo. Lycoming T-53 turboshaft produces 1,400 shop. Cruise speed reaches 204 kilometers per hour. Range is 510 kilometers with service ceiling of 4,200 meters. Single main rotor, tail rotor configuration. Large cabin doors enable rapid ingress and egress. Simple hydraulic systems and reliable turboshaft engine. Limitation is vulnerability in contested airspace and limited payload compared to modern helicopters. Flight hour cost of $500 to $1,200 versus modern helicopters at $3,000 to $8,000. For non-combat missions, cost difference is unjustifiable. Adequate for medical evacuation, VIP transport, and light cargo in non-hostile environments. Commercial maintenance available with continued parts production. Modern avionics, GPS, and communication systems integrate without airframe replacement. Limited U.S. National Guard and test units. Extensively operated by Philippines, Colombia, Japan with license-built variants, Taiwan, Thailand, Uruguay. Serves in medical evacuation, utility transport, VIP movement, firefighting, counter-narcotics operations, and search and rescue. The M114 155mm Howitzer entered U.S. service in 1942 as a successor to World War I-era heavy artillery. Designed for corps-level fire support, it provided long-range indirect fire during World War II, Korea, and early Cold War planning for large-scale conventional warfare in Europe. The system reflected mid-20th century artillery doctrine, deliberate, sustained fire from prepared positions rather than rapid maneuver warfare. Thousands were produced, and the howitzer was exported widely under military assistance programs, embedding it into Allied artillery structures worldwide. The M114 uses a 155mm 23 caliber barrel with a maximum range of approximately 14.6 kilometers using standard high explosive ammunition. The system weighs around 5,800 kilograms and requires a crew of 11. It fires separate loading ammunition with bagged propellant charges, allowing flexible range adjustment. The split-trail carriage provides stability, while the absence of complex hydraulics or electronics simplifies operation and maintenance. The system is fully compatible with standard NATO 155mm ammunition. Limitations include short range compared to modern howitzers, slow displacement, and vulnerability due to lack of armor. Despite its age, the M114 remains useful in static or defensive roles where mobility is not critical. Its simplicity allows operation by reserve forces with limited training. Maintenance can be conducted with basic mechanical skills, and ammunition compatibility eliminates the need for unique supply chains. In low-intensity conflicts, territorial defense units, or training roles, replacing the M114 with modern artillery systems offers little operational benefit relative to cost. The weapon still delivers high explosive payloads equivalent to modern guns. Physics has not changed. Limited numbers remain in service with reserve, training, and territorial defense units in parts of Asia, Africa, and the Middle East. Some nations retain them for coastal defense, static artillery positions, or emergency mobilization stockpiles. Others use them exclusively for training artillery crews before transitioning to modern systems. Developed in the mid-1950s as a lightweight supersonic interceptor, the MiG-21 addressed Soviet requirement for mass-produced air defense against NATO bombers. Designed for simplicity, high performance, and operation from austere airfields. First flight in 1955, entering service in 1959. Over 11,000 produced, most produced supersonic fighter in history. Single-seat fighter with one Tamansky R-25 turbojet producing 40.21 knots dry thrust, 69.62 knots with afterburner. Maximum speed exceeds Mach 2.05. Combat radius approximately 370 kilometers. Service ceiling of 17,500 meters. Armament includes one 23mm cannon plus air-to-air missiles or rockets and bombs. Delta wing design with small radar cross-section. Limitation is short range, limited payload, and minimal avionics in early variants. Modernization packages include improved radar, avionics, weapons integration, and cockpit upgrades at $2 to $4 million versus $25 million for new fighters. Adequate for air policing, ground attack in permissive environments, and training. Millions of spare parts in global circulation. Simple maintenance requirements suit nations with limited technical infrastructure. Active service in India, which is phasing out Croatia, Romania, Syria, North Korea, and various African nations. Employed for air defense, ground attack, advanced training, and aggressor squadrons simulating enemy aircraft. Designed in the early 1950s to replace piston-engine tactical transports, the C-130 addressed requirements for rough field operations, paradrop, and tactical cargo delivery. First flight in 1954. Continuous production since 1954 makes it the longest continuously produced military aircraft with over 2,500 built. Crew of 5. Pilot, co-pilot, navigator, flight engineer, loadmaster. Payload of 19,000 kilograms cargo, 92 troops, or 64 paratroopers. 4 Allison T-56 turboprops producing 4,590 shop each. Range of 3,800 kilometers with maximum payload. Cruise speed 540 kilometers per hour. High wing configuration for ground clearance. Rear cargo ramp for vehicle loading and paradrop. Capable of operations from unpaved runways under 1,000 meters. Limitation is relatively slow speed compared to jet transports. Operates from austere airfields that modern jets cannot access. Essential for humanitarian relief and special operations in remote regions. Carries outsized cargo that strategic transports cannot efficiently deliver in small quantities. Lower operational costs than strategic airlifters for regional missions. Modern C-130J variant shares airframe with continuous upgrades. Over 70 nations operate variants. U.S. operates 400 aircraft. Variants include AC-130 gunship, KC-130 tanker, EC-130 electronic warfare, HC-130 search and rescue. Serves in tactical transport, humanitarian relief, special operations support, aerial refueling, firefighting, and weather reconnaissance. These 9 systems, and dozens more like them, persist because military effectiveness depends on context, not specifications. The M2 Browning provides capabilities no modern weapon replicates at comparable cost. The B-52 delivers payloads more economically than alternatives. Replacement costs extend beyond unit acquisition to ammunition stockpiling, training, parts logistics, technical manuals, and doctrine revision. Total lifecycle cost, purchase price plus decades of operation and support, often favors retention and modernization over replacement. Effectiveness depends on matching capabilities to threats. The RPG-7 remains effective because most armored vehicles globally lack advanced protection. The M113 remains sufficient because many conflicts involve adversaries without modern anti-tank weapons. Weapons systems exist within support ecosystems. Global adoption created manufacturing capacity spanning continents. Infrastructure representing decades of investment cannot be casually discarded. These weapons remain in service, not from institutional inertia or budget failures. They persist because military procurement operates according to logic different from civilian markets. These systems represent proven designs refined across decades. They exist within established logistics networks. They match capabilities to actual threats. They provide cost-effective solutions to missions not requiring cutting-edge technology. This isn't nostalgia. It's rational resource allocation. In military affairs, newer and better are not synonyms. Effectiveness is contextual, and longevity often indicates not obsolescence deferred, but design excellence achieved.